Okay, so here's a last example for this section regarding using CAS. Okay, so this again is a short section. So using the computer algebra system for calculating integrals, we're going to use Wolfram, and then we're going to compare it with what you would get if you did it by hand, and what we would get it just applying the techniques that we've learned. So now, again, we would use the power reducing. So in this case, we have an odd power of sine, so we could easily integrate this by using those techniques that we learned in previous sections. But if you use Wolfram Alpha or maybe some other CAS, you would get this. So if you put this in Wolfram Alpha online, or you're going to get something, maybe get something like this, where you have 1/12 cosine 3x minus 9 cosine x plus c. Now, compare that with what you would get by using the techniques that we've learned here in solving sine cubed x. Okay, so now these are exactly the same. So that's, again, I'm going to reiterate that. Make sure that you understand what you're getting, and just make sure that you're confident in your ability to integrate these, because again, just because you get something different than what's in the back of the book doesn't mean that your answer is necessarily wrong. Okay, for example, if this is from this computer algebraic system, let's see, so if we start with this, let me do this. So we start with 1/12 cosine. I'm going to rewrite this here. So I'm going to rewrite this a little bit differently. So this is 12, and I'm going to write this as cosine x plus 2x minus 9 cosine x. I'm going to drop the c for right now. Okay, and so now I'm rewriting it this way so I can use an identity. So this identity is going to give me 1/12, and this is going to be cosine x cosine 2x minus sine x sine 2x minus 9 cosine x. Okay, so what I did was I rewrote this as this piece right here using the sum of angles, right? So this is the sum of two angles. So I can use this cosine as this. So that decomposes as that. Now what I'm going to do is I'm going to use the identities that involve double angles, okay, for cosine and for sine. Now there's more than one identity that you can use for this, but again, we're trying to get to this, cosine cubed. So I need to get cosine squared in here. Okay, so the one that I'm going to use for cosine squared is going to be oops, okay, 2. Okay. Let me do this. That. Okay, so I just replaced cosine 2x with that one. Okay. And then the other one here, this one here, sine 2x. Now I can also do another, excuse me, sorry, with sine. Okay, so sine 2x, we could use another double angle identity, and that's going to involve a product. Oh, wait a minute. I've dropped my sign. So minus sine x. And then this is going to be okay. So I know it's getting a little messy. So what we did was we replaced this with this, okay? And we replaced this with this, okay? And then of course we're keeping that. And so now, what do? We're going to end up with, let's simplify this a little bit. So now we're going to simplify this and see what we end up with. So we're going to end up with 2 cosine cubed x minus minus cosine x minus 2 sine squared x cosine x minus 9 cosine x. Okay. Oh, hold on. I didn't want to do that. Minus sine x. And then this here I wanted to rewrite that a little. Yeah, no, actually that's good. Yeah, that's fine. Okay, we'll do one more step. So this is sine squared x, so 2 sine squared x cosine x minus 9 cosine x. Okay, so I'll leave it the way it was. So I just want to make sure. So 2 cosine cubed x minus cosine x minus 2 times sine squared x cosine x minus 9 cosine x. Okay, so now I'm going to replace this with cosine because that we need to get rid of that sine. So I'm going to use the identity. So let's do it this way. So we'll have 1/12 2 cosine cubed x minus cosine x minus 2 cosine x, and then we're going to have, well, we're going to use the Pythagorean identity here. So this will be 1 minus cosine squared x minus 9 cosine x. Okay, now so far so good. reduced to what do we have here? Yeah. So let's go back up to here. I'm going to not erase this because that's what we're looking at. So now, what happens here? This becomes 1/12, and this is 2 cosine cubed x minus cosine x. Now this is going to be distributed, so this is going to be minus 2 cosine x plus 2 cosine cubed x minus 9 cosine x. Okay, so now things are going to simplify. So this will be 1/12. And so 2 cosine cubed x plus 2 cosine cubed x gives us a 4 cosine cubed x. And then we got a minus cosine x plus 2 minus another 2 cosine x plus minus another 9 gives us minus 12 cosine x. Okay, and so here we go. This is the end. We're just about there. So now all I have to do is factor out a 4. And I've got my 1/3. So if I factor out a 4, yeah, so factor out a 4, or in other words, I can distribute the 1/12. That's what I'll do. So if I distribute the 1/12, then I get 1/3 cosine cubed x minus cosine x, and then of course the plus c. And I'm done. So they are the same. Okay, so again, just be careful when you use computer-aided or computer algebra systems that your answer may not be what you would get if you did it manually, in other words, or straightforward using the properties. But they are the same in this case. Okay, that's it. Have a great day.